Hey guys, we are going to start a new unit. This is actually lesson one, and it's going to be broken into two parts because there's a lot to cover. The main thing I want you to take away with this lesson is we're talking about inverse functions. So remember, let's go back to like an algebra 2 perspective. So if I have the function like y equals 2x plus 1, the inverse is we switch x and y. So x equals 2y plus 1, and then solve for y. So y equals x minus 1 divided by 2. So you should be really familiar with that. You should also be familiar with the fact that like the cubed root of x and x to the third power are inverses of each other. X to the third power, the graph, sorry, that looks hideous, goes something like that. And the cubed root of x does something like that. So notice it's like flipped on its side. Um, some of these are going to look like that. Some of these are not. So I want to start with one that may be like more familiar territory. Actually, tangent is the one that's going to like follow closest to this. So remember the tangent, if we were to make an XY chart for tangent, when we were doing the graphing functions, we did negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. And if you'll recall, it went undefined, undefined, 0, and then tangent went up. So it went from -1 to +1. Okay, well, so we are going to find the inverse of this now. And so we are going to flip these. So if you'll remember, the graph went, I'm trying to figure out a place to put it. The graph kind of looked like a cubic function. So the tangent inverse graph is going to be very, very similar looking to the cubed root function. So remember, all I'm doing is flipping those x and y values. So instead of like negative pi over 2 undefined, I'm going to have undefined negative pi over 2. -1, negative pi over 4, 0, 0, 1, pi over 4, and undefined pi over 2. So I'll go ahead and graph this. So let's see, my x value, I'm going to do my y values like this. Oops, pi over 4. Let me erase that. Okay. Okay, so remember these y values used to be our x values. And so our former x values are now, or sorry, our former y values are now our x values. So we have undefined, undefined, and then we have -1. I'm just going to call that -1, and this is +1. So undefined, negative pi over 2, let's not worry about that yet. So I have -1, negative pi over 4. Let me do this in a different color. Sorry, it's going to be right in between there. 0, 0, and then 1 pi over 4. So it looks like that. So if you'll recall, this is going to go towards this asymptote here. That's where that undefined's coming from. Oh, sorry, this undefined's coming from. And then this negative pi over 2, that's coming from that undefined. And so what happens is it goes through that. And again, it looks very similar to that cubed root function. Okay, something else that I want to bring up with tangent is, let's talk about the domain and range. So the domain for tangent, notice it's going to be the set of all reals because it's going to go to the left forever and to the right forever. You can put negative infinity to positive infinity as well. The reason I'm putting it in this form is because some of these are going to require this form. This one does not. Okay, so this one, notice like how high does it, or how low does it go to how high does it go? So it goes from negative pi over 2 to positive pi over 2. And notice, like, if you're doing the set notation, it would be parentheses because it doesn't touch negative and positive pi over 2 because those asymptotes are there. Okay, so this is going to be pretty important moving forward as well as the graph. So this is actually, tangent's usually the yucky one. This is actually like the easiest one to wrap our mind around. Sine and cosine are a little bit different. So that's why on Monday when we meet, I'll kind of be going into why this is the way it is. But let me just kind of give you a brief overview. So sine, if we were to graph a sine function, it would do this forever. So if you'll remember, something else about inverses is that this isn't one-to-one because it doesn't pass the horizontal line test. So we have to limit it. So we are going to limit the domain and the range. And again, I'll explain why on Monday. So think about a regular XY chart. I'm going to squeeze this in here. So remember our sine graph for the y's, it would range from -1 to +1. It would go in that realm, whether it's sine or cosine. Well, so this is going to be our x values. So for that reason, sorry, it's going to look like that. And notice that it is equal to, because it actually does touch the -1 and +1. Okay, our range, we are going to limit it. And again, it's because we can't, we can't have it the whole thing. So we are going to limit it to -pi/2 to +pi/2. Okay, and so let's go down here and notice that's the same range as down here for the tangent functions. Okay, so again, my handwriting looks terrible, but this is -1 to +1 for my domain, and my range is going to be -pi/2 to +pi/2. Okay, so our new XY chart is going to be, I'm just going to write it out because we're going to talk about this on Monday. Sorry. Square root of 2 over 2, -pi/4. Zero, zero. Positive square root of 2 over 2, pi/4, and 1 pi/2. Okay, so a few things I want to point out is that this is going from, so think about like the unit circle. So this is going from -90 degrees to +90 degrees. So that's going to be kind of important later. Okay, so think about sine on the unit circle. So at -90 degrees, your sine value is -1. And for +90 degrees, your sine value is +1. Also, again, on the unit circle, think about 0 radians. We're going to have 0. And then we have pi/4. Remember, that's like 45-degree angle. So now we have like -45 degrees. So that's in that quadrant 4. So it's negative square root of 2 over 2. And then +45 degrees is positive square root of 2 over 2. So I'm going to go ahead and graph this. So I'm going to start with 0, 0. And then square root of 2 over 2. Let me type it in my calculator. That's like 0.7. So this is 0.7. And pi/4 is about 0.8. So I call that one and that one. Let's do like right there. Okay, and then 1 pi/2. And pi/2 is about 1.6. So it looks like that. Okay, so I've got that one, that one, that one. Okay, so we're going to do the same thing. So it looks something like that. So when you graph it, guys, there's not going to be any arrows. It stops there. So it's just these 4 points that you see right here. Okay, cosine is going to be the same thing, same process. So I'm not going to go through it. I'm just going to write the XY chart. So this is for cosine. Sorry, this is looking very sloppy. So 1, 0, square root of 2 over 2, pi over 4. Again, so at a 45-degree angle, square root of 2 over 2. That makes sense to us. 0, pi over 2. So the cosine of 90 degrees is 0. Negative square root of 2 over 2, 3 pi over 4. And then negative 1 and pi. So this is going to be your cosine XY chart. So let's talk about the domain. So the domain is going to go from -1 to +1. Again, that doesn't change. So think about like our original sine and cosine graph. And then our range is going to go from, let's look at it, from 0 to pi. Like that. So I was thinking if you want to do these in like interval notation, that's okay as well. It's just up to you. Okay, so the graph for the cosine, just go ahead and graph this. So 1, 0, square root of 2 over 2, that was 0.7, then 0.8, so it's going to look like that. 0 pi over 2, so about there. And then negative pi over 2 over 2, which is negative about right there. And then 3 pi over 4. I don't know what that is. That's about 2.35. So right there. And then what's the final one? Negative 1 pi. So 3.14. So it looks like that. Ugh, this looks really hideous the way I did it. It should look like that. So hopefully you guys are a little bit more careful when you do that. But again, you're going to stop here and stop here. It's not going to be an arrow. This one is the only one with arrows because it continues on and on forever. That's why it's a set of all reals. But these have like a definite stop or beginning and end. Okay, so that's all I want to talk about on this page. And then I think we can knock out the rest of the lesson in the next video.